Understanding the difference between bits and bytes is essential for anyone working with digital technology, from storage capacity to internet speeds. These two units form the foundation of how computers process and store information. A bit, short for binary digit, represents the smallest possible unit of data in computing. It exists in one of two states: 0 or 1, off or on, false or true. This binary system mirrors the fundamental nature of electronic circuits, which can either conduct electricity or not. Every piece of digital information, whether text, images, video, or software, ultimately breaks down into sequences of bits. A single bit carries minimal information on its own, capable of representing only two possibilities. However, when combined, bits create the complex digital world we interact with daily. A byte consists of 8 bits grouped together. This grouping emerged as a standard because 8 bits provide enough combinations to represent meaningful data. Specifically, 8 bits can create 256 different combinations, calculated as 2 to the 8th power. This capacity of 256 values proves particularly useful for encoding characters. The American Standard Code for Information Interchange, commonly known as ASCII, uses 1 byte to represent each letter, number, and symbol on a keyboard. For instance, the uppercase letter A corresponds to the binary sequence 010000001. The relationship between bits and bytes follows a straightforward mathematical pattern. 8 bits equal 1 byte, meaning a file size of 64 bits translates to 8 bytes. This conversion factor remains constant across all digital systems and applications. When discussing data transfer speeds, the industry typically measures in bits per second. Internet service providers advertise connection speeds in megabits per second, abbreviated as MBPs. A connection rated at 100 megabits per second theoretically downloads 100 million bits every second. Storage capacity, however, uses bytes as the standard measurement. Hard drives, solid-state drives, and memory modules display their capacity in gigabytes or terabytes. A 1 terabyte hard drive holds approximately 1 trillion bytes, or 8 trillion bits of information. This distinction between bits for speed and bytes for storage creates occasional confusion. Downloading a 1 gigabyte file on a 100 megabit per second connection takes longer than one might initially expect. Since 1 byte equals 8 bits, the actual download speed in bytes per second is the advertised speed divided by 8. Larger units build upon bytes using powers of 2 or powers of 10, depending on the context. A kilobyte traditionally contains 1024 bytes. A megabyte contains 1024 kilobytes, and a gigabyte contains 1024 megabytes. These values stem from 2 to the 10th power, which equals 1024. The computing industry also uses decimal-based measurements, where a kilobyte equals exactly 1000 bytes. This discrepancy between binary and decimal measurements has led to the creation of distinct terms: kibibyte for 1024 bytes and kilobyte for 1000 bytes, though common usage often blurs this distinction. Bits serve as the atomic units of digital information, representing individual binary states, while bytes function as practical containers of 8 bits, suitable for encoding characters and measuring storage. Understanding this fundamental difference clarifies how computers quantify data transfer rates in bits and storage capacity in bytes.